Section 10.1, the Law of Cosines. Our objective is to solve oblique triangles using the Law of Cosines. So in Section 6.1 and 6.2, we learned right triangle trigonometry and its applications. So we have learned how to solve right triangles using our trig ratios and the Pythagorean theorem and the triangle sum theorem. So now the question is, what happens when we don't have a right triangle? How do we solve for that other side or other length that we have? We can use what's called the law of cosines. So oblique triangle, remember, is a triangle that does not contain a right angle. So here are some examples of oblique triangle. Another thing we need to talk about is our standard notation. Remember that each vertex is labeled with a capital letter, and the length of a side opposite that vertex is denoted by the same letter in lowercase. So if you'll note here that this is a capital B, so the opposite side of that would be lowercase b. If this is A, then opposite that would be lowercase a here, and then the same thing for C. So remember that that's how you label your triangles. So let's go ahead and look at the proof for the law of cosines. So if we were given side B and C and angle A, so notice that angle A is in between B and C, we can find the length of side A using our law of cosines. So let's go ahead and derive this first, which is already written here for you. You don't need to know how to derive this, but it's just to show you how you get the law of cosines. So if we made this into a right triangle, as you see that I did here with that blue, I have this as length x and the height as length y. Well, if we wanted to find what the what x is equal to and what y is equal to, that's when we used our trigonometry. So we had the cosine of A is equal to adjacent over hypotenuse, so that would be x over b. So if we solve for x, we get x is equal to b times cosine A. And for sine of A, to find y, we do opposite over hypotenuse. So my opposite is y, and my hypotenuse is b here from sine of A. So then we can solve for y and say y is equal to b sine of A. So that's stuff we've done before. And again, that was just using a right triangle, this being A, this being B, and we were calling this X and this Y. Now, with that, we can use it to figure out the law of cosines. Now, for this, remember that we know the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Well, in this case, we don't have a right triangle, so we can't use that. But what we do know is we can use the distance formula when you subtract the 2 points. So if I wanted to find this length here, which is side A, or this side A here, I know that C is the point X and Y. Well, then I also know that this point right here is really a length of C, comma, height of 0. So I can use this as C, comma, 0. So to find the distance of side A, you subtract the 2 points. So that's where we get X minus C squared plus Y minus 0 squared. And then, of course, you take the square root of that because it's really A squared equals that. So we don't want to have the square root of our formula, so that's why right here we're going to square both sides. Then the next step is we took the x minus c squared and FOILed it out to get this step right here. And after you FOIL it out, notice that, well, we don't know what x and y is in our equation, but we do know what x is equal to b times the cosine of A, or y is equal to b times the sine of A. So what I did after I FOILed it is I replaced this x right here with b cosine A, and I replaced this x with the same thing, b cosine A, and then I replaced this y with b times the sine of A. So then I just distributed using my properties of exponents. So a squared equals b squared times cosine squared A minus 2bc cosine A plus c squared plus b squared sine squared A. And then for this, I did a little bit of rearranging. So I rearranged the equation and I put these two together because I noticed that I could factor out that b squared right here to get cosine squared A plus sine squared A. And remember, cosine squared A plus sine squared A is a Pythagorean identity, which equals 1. So this right here is really gone. And you're left with b squared plus c squared equals 2bc cosine A. So this right here is my law of cosines, and this helps me solve for the missing length of a triangle if it's not a right triangle. So let's go ahead and look at this in some more detail. So let's say we had this triangle right here, and we were given, let's say, side C, side B, and angle A, and we wanted to solve for this side A right here. So if I wanted to solve for A, I have A squared equals B squared plus C squared minus 2BC cosine A. Notice that here, if we're solving for side A, you're taking the cosine of that angle, and then you're adding the other two lengths that you already have in the problem, minus 2 times the two lengths. So let's say instead we wanted to solve for side B. If I wanted to solve for side B, then I would have to know angle B, side C, and side A in order to solve for B. So in this case, then the side that I'm solving for would be B squared equals, I'd take the other two lengths, A squared plus C squared minus 2 times those lengths, A and C, and then I do the cosine of the angle of the side I'm trying to find. So that would be if I'm trying to solve for length B. If I'm trying to solve for side C, and I knew what side A and side B was and angle C, then I can solve this by doing C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. So these are my law of cosine formulas solving for the different sides that I have. So you need to know each of those. And again, in order to do this, you need to know the angle that is included between the two sides that you have. Also, something else that I didn't mention was that your calculator needs to be in degree mode. When we're solving triangles, we always use degrees. We don't use radians, so make sure you change that if you haven't already. Now, we also have alternate forms for the law of cosines. So some alternate forms that we have is by solving for the angle. So let's say you were given all the sides and you wanted to find the cosine of A. Well, I'm going to write this out again. So we have A squared equals B squared plus C squared minus 2BC cosine A. So let's say I wanted to solve for the angle if I knew all three sides. So in this case, then I would subtract the B and subtract the C to the other side. So I have A squared minus B squared minus C squared equals negative 2BC cosine of A. And then, of course, I would divide both sides by negative 2BC. So this would be gone, and I'd be left with the cosine of A is equal to, normally we don't like to have negatives in my denominator, so I'm going to take that out by changing all the signs in my numerator and switching it around a little bit. So we would have, if I had changed, A would be negative, B would be positive, and C would be positive, so I would write that as B squared plus C squared minus A squared over 2BC. So this is my alternate form for the law of cosines. Now notice when you're solving this one, if you're trying to find the angle A, you take the two lengths that you're given, add them together, subtract the side of the angle that you're trying to find over 2 times BC. So let's do the other two. So I'm just erasing that so I have room to write them. So if I wanted to find cosine C, so angle C, then to find angle C, the cosine of it would be equal to, in this case, A squared plus B squared minus C squared over 2AB. And of course, in order to solve for C, I would have to do the cosine inverse, which we'll do some of those problems in a little bit. So then the last one would be, if I wanted to solve for cosine B, it would be equal to A squared plus C squared minus B squared over 2AC. And again, make sure you know those formulas. So it's easy to remember that here, if you're trying to find that angle, then that's the one that you subtract over here. Now, to use the law of cosines, you can use it in the following two cases. When you know two sides and the angle between them, and remember from geometry that means you have a side, angle, and a side, Or if you know all three sides, then you can solve for the angle using the alternate form of the law of cosines. So just to kind of look at these triangles, this would be a side, the included angle, and a side right here. So this would be the included angle. So if I have that, then I can solve using the law of cosines. Or I could switch it up. I could do this side, that angle, and that side there. So again, this would be side, angle, and then side, and again, side, angle, side. So it has to be included. If I have something like this right here, an angle, a side, and an angle, I cannot use the law of cosines. The reason I cannot use the law of cosines is because notice that each of the formulas, I had to know either two sides and the included angle, or I had to know all three sides. So I cannot use these for the law of cosines. And the last one, if I know all three sides, so if I know side, side, and side, I can use the alternate form to find the angles. So let's do some practice of these. Now, again, make sure your calculator is in degree mode. If it's not, make sure you change it. Now, when I'm doing these problems in my calculator, I always make sure to not round until the very end, so I keep everything in my calculator. And also, as I'm doing this, you're going to want to practice plugging it into your calculator, because I find that most of the times the students can do the formulas, but the problem occurs when they try to plug it into the calculator, they end up plugging it in correctly. So be very careful with how you plug these in. So for the first one, it says solve the triangle below. So we're going to solve for the missing angles and also the missing length C. So notice I have a side, an included angle, and a side. So this is side, angle, side, which means I can go ahead and use the law of cosines. I'm just going to make another note up here. You want to be in degrees. Now, for this, if I want to solve for side C, let's go ahead and do that first. So C squared would be equal to, in this case, 10 squared plus 16 squared minus 2 times 10 times 16, and then the cosine of the angle, which it would be 110 degrees. So this is the equation that we are solving right here. So again, make sure your calculator is in degrees, and then I'm going to plug all of this into my calculator, and then to solve for C, you have to do the square root of all of that. So really, I'm doing the square root of all of this in my calculator, 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of 110 degrees. So if you do this, I would do everything and then take the square root of the answer in your calculator, and we're going to round to the nearest tenth. So don't round your answers until the very end. So if you do this in your calculator, you should end up with a C value being equal to 21.6. So now I have what this side here is equal to. Now I need to solve for angle A and angle B. So if I have all three sides, I can use the alternate form for the law of cosines to solve. So let's do that. So the cosine of angle A would be equal to the two sides that we know. So 10 squared plus my C squared, which we just found was 21.6, minus the side of the angle we're trying to find, so 16, over 10 squared, oops, not squared, 2 times 10 times 21.6. So for this problem, be careful in your calculator to, if you do this all together, to make sure the numerator is in parentheses and put all of this in parentheses when you divide it. So when you do that in your calculator, you're going to end up with the cosine of A is equal to some decimal, which is about 0.7188, and just leave the whole thing in your calculator. So remember, in order to solve for A, we have to use our inverses. So A is equal to the cosine inverse of your answer, 0.7188. So A in your calculator would be really equal to 44.2 degrees. And again, make sure you don't round to the very end, and of course make sure you plug that in to make sure you can find that. And if I know A angle A and angle C, I can use the triangle sum theorem to solve for B, because B would be equal to 180 degrees minus 110 degrees minus 44.2 degrees, because remember, all the angles in a triangle have to add up to 180 degrees, which ends up giving us 25.8 degrees. So that would be for B. So now I found everything that I need to find in my triangle. So let's look at number 2 here. So for number 2, it says we want to solve the triangle below. So for this triangle, we are given all 3 sides. So side, side, side. So if I'm given all 3 sides, that means I can use the law of cosines. And in this case, I'm going to have to use the alternate law of cosines because I'm trying to solve for the angles. So I'll do the first one and then you guys can go ahead and finish it. So if I want to find the, let's do the cosine of angle C. So if I want to find this angle here, notice that the side opposite is 8.3, and that means I'm going to add this side and subtract the 8.3. So cosine C is equal to 15 squared plus 20 squared minus the side opposite the angles, which is 8.3 squared, divided by 2 times those 2 sides that you have, 15 and 20. Don't forget to make sure your parentheses are in the correct place. So when I do that on my calculator, I get all of this is equal to 0.92685. So to solve for the cosine of C, because we really have the cosine of C equals 0.92685, I want to do the inverse. So the cos C is equal to cosine inverse of 0.92685. And when you do that, you round to nearest tenth and you get 22.1 degrees. Make sure that you label this as degrees since that's what we're working with. So now you guys need to find angle A and angle B, and I'm going to write the answers down here, but you need to work them out to make sure that you can find it. So angle A would be equal to, I have 115.2 degrees, so make sure you can find that. And I know that B is going to be equal to 180 degrees minus 22.1 degrees minus 115.2 degrees, which is equal to, in this case, 42.7 degrees. So make sure you can find those on your own. So for this next one, it says find the angles of R, S, and T shown below. So this is just like the problem we just did. So let's go ahead and skip this one and go to the next. Now we have a couple of word problems. So I want to look at this word problem together. For this word problem that we have, it says 2 trains leave the station on different tracks. The tracks are at an angle of 125 degrees with the station at the vertex. The first train travels on an average of 100 kilometers per hour, and the second train travels at an average of 65 kilometers per hour. How far apart are the 2 trains after 2 hours? So now I would challenge you guys to pause the video here and take a second to see if you can make a picture of this and see if you can work it out, and then unpause it and I'll show you the answer. So here's our picture so far. So we have our station, and it says the 2 trains leave the station on different tracks, and they make an angle of 125 degrees with the station at the vertex. So that's why we have this picture looks like this. Then the other thing says we want to figure out how far apart are the 2 trains after 2 hours. So we're given that train A is traveling at a rate of 100 kilometers per hour and train B is traveling at a rate of 65 kilometers per hour. So if we want to find how far they are apart after 2 hours, we need to multiply each of these by 2 to figure out the distance that they have traveled. So this would be 200 kilometers per hour and 130 after, or per 2 hours, I should say. So then I know that side B is going to be from the station to train A. So this one is a little bit harder. So from the station to train A has traveled 200 kilometers in 2 hours. And from the station to train B here, we have traveled 150 30 kilometers per the 2 hours. So now I want to figure out how far apart these are. So I'm trying to figure out this distance right here. So of course I have a side, the included angle, and a side, so side angle side, which means I can use the law of cosines. So in this case, this is side C, that's what we're trying to solve for. So C squared equals 130 squared plus 200 squared minus 2 times 130 times 200 times the cosine of the angle 125 degrees. So I'm going to do that all of my calculator, and then I'm going to take the square root of my answer. So for this one, I'm doing my calculator and then take the square root, you end up with 294.5 kilometers apart after 2 hours. So that would be our answer. So let's go ahead and do one more problem. So for this next problem here, we have a 100-foot tall antenna tower is to be placed on a hillside that makes an angle of 12 degrees with the horizontal. If it is to be anchored by 2 cables from the top of the tower to points 85 feet uphill and 95 feet downhill from the base, how much cable is needed? So see if you can pause the video and draw a picture of this, and then unpause it and we'll look at it together. So I'm going to start. First we have our hill. So this is my hill right there. Then it says that we know the hillside makes a 12 degree angle with the horizontal. So the horizontal would just be like kind of like thinking about the horizon. So this would be the horizontal. It's a horizontal line. So I know that from here to here, this is 12 degrees with the horizontal. Then it says that we have some antenna tower that is 100 feet tall. Pretend that's straight. So this is 100. And we know that we're going to place a cable 85 feet uphill. So from here to here, this is my cable. So this is 85 feet uphill. And then downhill, which would be this length right here, is going to be 95 feet. Now we want to figure out how much cable is needed. So we need to figure out this length here for the cable and the length at the top for the cable. So let's go ahead and just do a little bit of labeling. I'm going to call this B here. Let's call this C, and I'm going to call this D. So I'm going to call this B1, and then I'm going to call this B2. Now for this, we have a bunch of sides, but we don't have the angle included right here in order to solve for B1, and we don't have this angle right here in order to solve for B2, because you need a side angle on the side. So how can I find those? Well, if you think about it, I'm going to erase this B right here. If I were to extend this down, I know this is going to make a right triangle right here. So if that makes a right triangle, then I can figure out what this little angle in here is going to be by using my triangle sum theorem. So that angle in there is going to be, so we'll call that angle, I'm going to call this E right here. So angle measure of CBE would be equal to 180 degrees minus 90 degrees minus 12 degrees, which gives me 78 degrees. So if I know this is 78 degrees, then I can figure out what this angle is by using the supplementary angles postulate. So for this one, I can figure out what the angle measure of CB, and let's call this up here A. So this angle right here, by taking 180 degrees minus 78 degrees, which is 102. So I know that this angle measure right here is 102 degrees. And again, by the supplementary angles, I can figure out that this angle, by subtracting 180 minus 102, I know that this angle measure is going to then be 78 degrees right there. So now I have all the information I need in order to solve for B1 and B2. So for this, because I have a side, the included angle, and the side, I can solve for B2. So B2 is equal to, and actually let's do it as B2 squared. So B2 squared, the length would be equal to 95 squared plus 100 squared minus 2 times 95 times 100 times the cosine of 102 degrees. So if you plug this into your calculator and solve, you end up with B2 being about equal to 151 point, I'm going to round to nearest hundredth, 58 feet. And now I can go ahead and solve for B1. So the length squared would be equal to, because don't forget you have to take the square root of your answer after you plug it into your calculator. So B1 squared would be equal to 85 squared plus 100 squared minus 2 times 85 times 100 times the cosine of 78 degrees. So when I plug this into my calculator and then take the square root of it, B1 is about equal to, I have 117.01 feet. And if we want to find out the length of the cable needed, then of course the length of the cable would be B1 plus B2. So I'm adding these two answers that I just got together, which ends up being about 268.59 feet of cable is needed. And that would be my answer. So I know there's two more problems on there, so hold on to those other two problems and we will get to them in class. But again, make sure that you know each of these formulas and how to find them and how to find the alternate form. So make sure you have those memorized. And again, remember when you're solving using the law of cosines, don't forget to take the square root of your answer. And then when you're solving for the alternate form, don't forget to do the cosine inverse of your answer in order to solve.